Unit 12 for your semester exam review, solving polynomials. You are allowed to use your calculator for this whole unit here. So start with number 1. It says factor completely and then determine the roots. So I have a trinomial, x to the 4th plus 5x squared minus 36. To factor a trinomial, we're going to use our regular factoring methods. Split the middle if you need to, or your regular trinomial pattern. Now, even though it says x to the 4th, this is going to factor as if this said x squared plus 5x minus 36. It's going to be the same way, except instead of just an x here, you're going to have x squared. So two numbers that multiply to negative 36 and add to 5 would be 9 and negative 4. Now that's not completely factored. I can factor this right factor as difference of squares. So x plus 2, x minus 2. And then the other factor is going to stay the same, x squared plus 9. That is prime. That one doesn't factor any farther because it's plus, not a difference. All right, now to find the roots, you use the zero product law. You're going to take each factor and set it equal to 0 and solve. So here, x plus 2, I would add, x minus 2, I'd add and get one of my roots to be at 2. The next one I'm going to subtract and get x equals negative 2. And over here I have to subtract 9. Get x squared equals negative 9. Take the square root of both sides. When you take the square root in these kind of problems, you have a plus or minus 3i. So those are your 4 roots here. Plus or minus 3i and 2 and negative 2. So plus or minus 2. That's how it's written on the back of your solutions. Now the number of real roots in this problem, there's 2 of them. 2 and negative 2. And then there's also 2 imaginary roots. All right, the next problem, number 2, factor to solve. I have 4 terms in this expression, so I'm going to try to factor by the method of grouping. All right, when I pull out a GCF from the first group, I'm going to have x squared times 2x minus 1. And the GCF for the next group, it's going to be negative because the third term is negative. I can factor out a negative 9, 2x minus 1. All right, what you see here will be x squared minus 9, that's one factor, 2x minus 1. And just like the previous problem, x squared minus 9 does factor by difference of squares. So it'll be x plus 3, x minus 3, and then the factor 2x minus 1. Again, we use the zero product law here, so I set each of these factors equal to 0 and solve them for x. So the first factor, when I solve it, I get negative 3. The second factor gives me positive 3. And here I have to add 1 first, and then divide by 2. So we get 1/2. So your roots here are 3, negative 3, and 1/2. That means there are 3 real roots. Those are all real numbers, and no imaginary roots in this problem. So if I graph this, it would cross the x-axis 3 times. All right, last factoring problem. X cubed plus 27. This is factoring a perfect cube using the method of SOAP. All right, now, remember, when you do SOAP here, you have a long set of parentheses and a short set of parentheses. You start by taking the cubed root of the first term. The cubed root of x cubed is x. That goes in the first blank. Then you take the cubed root of 27, which is 3. That goes in the second spot. I'll do the signs at the end. To fill in the first blank here and the long in your trinomial, you square the x. So you'll have x squared. To fill in the third blank of the trinomial, you square the 3, which is 9. And to fill in the middle spot, you multiply the 3 and the x together to get 3x. Now your signs, you use the acronym SOAP. Same, opposite, always positive. We have a plus to start, so that's your same sign. The opposite of plus is minus, always positive. That's the factored form. Now, in order to solve this, you have to use the zero product law. And for the zero product law here, I'm going to start by taking x plus 3, set it equal to 0, and subtract, and I get x equals negative 3. That is one of my roots. All right, now the other roots, I'm going to have to work with this trinomial here. Now, you can try to factor it, but it's never going to work. There are no two numbers that multiply to 9 and add to -3. This guy will always never factor. So you always have to use either the quadratic formula or complete the square. In this situation, we want to use the quadratic formula, not complete the square, because the -3, the b term, is odd. And complete the square is best used when you have an even middle term. So quadratic formula, if you don't remember it, x equals the opposite of b, plus or minus b squared minus 4ac under a square root all over 2a. So let's see, we'll jump back down. We have x equals the opposite of 3, positive 3, plus or minus the square root of -3 squared minus 4 times a times c all over 2a. Now, if I'm simplifying this, 3 plus or minus, don't put in your calculator what's under the square root. Or, I'm sorry, don't put the square root into your calculator, just the radicand, the discriminant, what's underneath the radical here. So you would take -3 squared minus 4 times 1 times 9, which is -27. So you have 3 plus or minus the square root of -27 all over 2. Now you need to simplify and break down that square root. Square root of 27, it has a negative, so it's going to have an I over here in my answer. 9 goes into 27. Radical 27 is equal to 3 radical 3. So it would be 3i radical 3 over 2. And that does not simplify anymore because the 3's and the 2's cannot cancel. So your other two roots here are those, and those are imaginary. So this problem has one real root, -3, so it only crosses the x-axis one time, and it has two imaginary roots. All right, number 4 and number 5, synthetic and long division. We'll start with long division here. It's already set up for that situation. We have to use long division in this problem because when you divide by the factor of 2x minus 3, the algorithm for synthetic division will not work. So you have to do long division here. When we did long division, we said you always start with the first term and divide it by the first term of the divisor, right? The dividend is what you're dividing. The divisor is what you divide by. So off to the side here, 10x to the 4th divided by 2x is 5x cubed. I'm going to put that on top over my cubes. I'm going to keep everything lined up. And I'm going to multiply. 5x squared times 2x is 10x to the 4th. Remember, those first two terms need to stay the same. 5x cubed times -3 is -15x cubed. I put my parentheses and I subtract. Now when I subtract here, the first terms always go away. Then I carefully subtract -13 minus -15. That's an addition. -13 plus 15 is 2x cubed. Bring down the next term. And I start over. 2x cubed, first term, divided by 2x. Okay, remember, you're always dividing the first terms. 2x cubed divided by the 2x. All right, that gives me x squared. So I'll put plus x squared on top over the x squared. Now I multiply what's on the outside. So I'll have 2x cubed. That's a good thing. It's the same as what I wanted. Minus 3x squared. I put parentheses, a minus sign, and I subtract. The x cubes cancel. -7 minus -3. That's a -4x squared. And I'll bring down the next term. All right, so the next thing I have is I'm going to, again, divide the 4x squared, my first term here, by the 2x. So 4x squared divided by 2x is equal to 2x. So I multiply. 2x times 2x is 4x squared. Oh, did I mess up there? I forgot the negative. -4x squared would give me -2x. So on the numerator, I have in the quotient, I have minus let's start this over. So x squared and then minus 2x. There we go. Okay, so that's a negative 4x squared plus 6x. Parentheses, subtract. The x's cancel. 8 minus 6 is 2x. Now write in a different color. 2x, bring down the 4. Last set of work. So I'm going to divide 2x by 2x. Okay? Equals 1. So I'm going to put plus 1 on the end. 1 times 2x is 2x. 1 times negative 3 is minus 3. When I subtract here, 4 minus negative 3 is positive 7. That's a remainder. So when I write the quotient, the answer here, I take what I have on the top of my division bar, 5x cubed plus x squared minus 2x plus 1, and my remainder is positive, so plus 7 over the divisor, 2x minus 3. Now, since there's a remainder, the divisor is not a factor of the original quartic polynomial. All right, next one, we're going to do, I would do synthetic division here. I'm dividing by x plus 2, and that follows the algorithm that the leading coefficient of the divisor is a 1. When I do synthetic division, it's important to remember that you need to make sure you have all of your exponents. I didn't talk about that in the long division. I have a 4, a 3. I do not have an x squared term, so I need to make sure I put a placeholder in for the x squared term. So what we do is we write the coefficients of each of these terms. A 3, a 6. I don't have a squared term, so I'm going to put a 0. I do have an x, and I have a constant. All right, now on the outside here, I'm going to set, remember, like we take the opposite, we take the root, basically. Find the root of that factor. We're figuring out if negative 2 is an x-intercept or a root. So I'm going to drop down 3. And I multiply. 3 times negative 2 is negative 6. Add those up and I get 0. 0 times negative 2 is 0. Add those up and I get 0 again. 0 times negative 2 is 0. Don't forget about these zeros. I add those up and get negative 2. Negative 2 times negative 2 is 4. And when I add those, I get an 8. And I remember, I like to put that in a box because that reminds me that that 8 is the remainder. Now here's the quotient. Remember when I divided x to the 4th by an x term, this dropped down the exponent by 1. So this is really 3x cubed, 0x squared, 0x minus 2. So really all I have to write here is 3x cubed minus 2. Plus I have a remainder of 8 over x plus 2. Because there's a remainder, this divisor is not a factor. All right, we'll get a little bit more practice with synthetic division here in number 6. Number 6, I think, is the last one of this unit. Yep. So number 6, you're going to need a calculator. So we're going to find all of the roots, real and imaginary and complex, of this polynomial. So the hint is use your calculator and use synthetic division. So the first thing I would suggest you do is to graph this polynomial in your calculator. Right, so we're going to graph 2x to the 4th minus 13x to the 3rd plus 23x squared minus 52x plus 60. Carefully graph it, and I'm going to zoom into my regular window, zoom 6. I don't really need to know anything else about the graph except where the x-intercepts are. So it looks like I have 2 x-intercepts. Let's trace them. It's going to be easier to trace them if you change the window a little bit. So I'm going to change the window. I can tell my y minimum is not far enough. So I'm going to change it to negative 100 and see. Maybe I'll go by 10s. And I can almost see the bottom. That's going to be good enough. So let's trace our x-intercept. I'll do the left one first. So here, if I go a little bit, there we go. All right, so I'm a little bit above to the left. Enter, go below, hit enter again. One of the roots is at 1.5. So take a minute, we're going to write that down on our paper. From our calculator, We know that a root is 1.5. We have to verify that, remember, using synthetic division. We have to do that proof. The second root, I'm going to chase the other roots. I'm going to go all the way over here and find the left bound of this root. Oops, too far. There we go. Left bound. Go to the other side. And that root's at 5. So I'm going to check, I'm going to verify that 1.5 and 5 are roots. Now remember, doing the synthetic division here not only proves to us that those are roots, it also allows us to lower the degree of the polynomial so that we can solve for the other roots. All right, so we're going to start with synthetic division. It does not matter which root you do first. So I'm going to have 2, the coefficients, -3, 23, -52, and 60. Now I'm going to do 5 first just because it's a whole number and that's a little bit nicer. When I do synthetic division here, I'm going to do it the same way I did in number 5. I'm going to drop down the 2 and multiply. 2 times 5 is 10. When I add these up, I get -3. 5 and -3 is -15. Add and get 8. 8 times 5 is 40. Add and get -12. And -12 times 5 is -60. That's a good thing. I get a remainder of 0. I know that 5 is a solution. Now, one thing I didn't mention, the degree of this polynomial, the highest exponent, is 4. We should have 4 solutions. So we found one of them. Now, we can continue on this synthetic division like trail here. And let's check the other root. We already used the simplified form. I started an x to the 4th. This is an x to the 3rd now, a cubic. So we're getting a little lower. Let's check 1.5. I'm going to bring down the 2. 2 times 1.5 is 3. Those add to 0. 0 times 1.5 is 0. Those add to 8. And 8 times 1.5 is positive 12. Those add to 0. Because the remainder is 0, we verified that 1.5 is a root. Now here's what I have. When I dropped down first, I started x to the 4th, I had x to the 3rd. Once I divided once. When I divide a second time, this is 2x squared plus 0x plus 8. That's the quadratic that I'm left with. I can now solve that and get my final 2 roots because I need 2 more. So I'll start by subtracting 8. Get 2x squared equals -8. Divide by 2. And then take the square root. Here, the square root of -4 is plus or minus 2i. So solving that problem gives me the other 2 roots. There are 2 imaginaries and 2 real roots there. All right, that is the video for, I'll bring it down because you need to see the work. That's the video for Unit 12. If you have questions, you need to check the Canvas, ask your teacher for help, or watch your old videos, do the quizzes, do the tests.